Hello everyone. Now we will discuss one problem what we have. In one project we need 11 temperature sensor. So we will using 11 temperature sensor, and we need some module to read all this sensor, and we will discuss which module we are using here and how we can read this 11 temperature sensor. Actually, if you want to use PLC extension module, so you need two or three extension module more than this one, but this one is very expensive, and now we will discuss how to use how we this cure this problem. Now we can together understanding. So we order one module, so this module is this name, so ZSOH. Okay, this one is PT100-16 channel. So with this module we can read 16 temperature sensor kind of PT100. So completely, but you need RS485. So we will communicate with this module, and how we can use that one now we will see. So when we ordered this device, this was very cheap, and they give us some files. So these files I found here. So they give us one manual and also one software. So these zips I unzip here. We have one software here. So, and also here another PDF files. So I translate this one with English, and now you can see here this one is PT100 temperature sensor. So something about this device. So here we have the parameters, power supplies. So this one is communication and temperature range. So maximum channel, so from 1 to 16. Also accuracy, speed, sensor type, 3 types, a communication protocol on RTU, so ASQ is not the reading. We have holding registers, read input register. Also we can write holding and multiple holding register we can write here. And about the address, what we have, baud rate. So this don't forget, any address when we want to change need to restart the power. Communication distance and parameter resetting, we have one buttons. Power communication. Okay, so this was about the parameters. So this is communication. We can also use PLC, HMI, so also PC. What do you want? You can communicate with this device. Here how to connect the sensor PT100. So this is 2 wires. That one is same in PT100, and this one is resistant wire you need to connect here. So this is also important. First time when you take this device, station address is 1 and baud rate is 338,400, data bit is 8, and stop bit is 1, parity is no. So this is the default setting. So what you want after you can change. So this is a reading and writing registers here. Okay, we need these registers. You can see here from the 0 hex to F hex, this is our channel. So from 0 hex, this one is channel 1, and F hex, this one is 16 channels. This is our register what we can do with this device. For example, I can change the speed or reading speed. I can also change the station address. I can change also baud rate, parity protocol. I can also I can change. So this is enough here. This was about this module. So also they give us this software when we open. You can see now I'm connected here. Just wait. I want to. Okay, I want to show you. So this is my device. So here is my power supply. If I change, maybe it's better. Okay, here is my power supply. And here A and B. You can see for the communication. A and B also I'm using the USB for the communication. Okay. Now I changed already my parameters. First time, if you want to communicate with this device, easily this device can from by this program can found easily. You need to put here station address 1. This is your station address, and this is your kind of module. My module is 16 channel, so this one is port which port you are connecting your USB to RS485. This is our baud rate, and this one is our parity. Here is known. Here is my parities event. If I want to connect here, now you can see here my first channel and 5 channel. I already connect the temperature sensor. So if I can show you here, this is my PT100. This is the 5 channel. So if I change temperature here, you can see now screen increasing. Temperature is increasing here. This is our software. How we can write something here? This means now we can communicate and we can read with the software. Also, I can by the Modbus pool, I can also communicate. No problem, easily. I go to connect. Just my COM ports found. Even this one is correct. Now this is my parameters, my communication parameter. So if you first time want to communicate, just check the min one. 96008 bits, priority is even, stop bit is 1. Okay. Now you can see here I'm also reading temperature here, channel 1 and channel 5. Channel 1 I will change temperature. You can see how it's changing here, 25 and 26. 26. Okay, this was, but if you want to change the parameters now, I want to write. If you want to something write to here, you just go to these parameters. Okay, if you want this address you need. Okay, for example, if you want to change baud rate, you can go here, this parameter 0033 hex. I can also do hex here. 33. Okay. Now you can see here my baud rate is 1. What was 1? 1 is 9600. But default, this is, you can see here, this is the default parity, default baud rate. If you can change, I change already. I put here 1. You can change right to inside the device. After, you need to restart the power, and again you can change your connection to this baud rate. Okay, this is about the communication with Modbus port. So I want just also with Kinco HMI, I just want to read this temperature. Okay, now I will open HMI, Kinco HMI. So this is my HMI here, and this is Modbus RTU device. So about the parameters, I'm using COM1. COM1, you can see here. This is 2-wire, and 96008 event 1. Okay, this is communication parameters. My station address is 1. So just here in Kinco HMI, when you give the address, for example, my address here written by X values. So you can just use calculator. Just you need to change this hex address to decimal after add to 1. This is according to our HMI Kinco, because when you want to read some address in Kinco HMI, you need to add this address to 1. For example, 0 hex, this one is decimal, also is 0, but you cannot read that. This one give you error. Need to add to 1. This means 1 address. This is your first channel temperature. And here you can see you need to use this 4 by 4x, and address from me is 1. This is my first channel. And 5 channel, you can see here by this address, if you want to read this one, need to 4 hex, but 4 with decimal also is 4. You need to add to 1 after becoming 5 address. Okay, this one is channel 2, but I'm not connecting the sensor. I will do compile, and we will write to the downside. I will explain you what I write there, and download. Okay, also I will okay. This is this is a little bit difficult to. About the communication, I'm just using this to wire number 1 and number 6. Number 1 is in HMI Kinco. Number 1 is positive, I think, and number 6 is negative for RS485. So this one is already connected. This module Now I have temperature here. Just wait. Like this. Also is not read. Okay, like this is better, no problem. As you can see here, I will change temperature here. 20. Okay, if I'm changing temperature here, you can see 25, 26. Also another one. This one is another one. I change channel 5 is changing. Okay. Now what I want to do, I just open another what I already make software. Now I just want to write this value inside the Mitsubishi PLC. This one is my Mitsubishi PLC. I am connecting to COM port 0. COM port 0 is also RS485 4 wires, and this is our parameters, our communication parameters. Okay. Yes, I will go here. This one is this one. Okay, just doing this one. I'm reading here, and this one is okay. 5 4, no problem. What we can do? Just we will use timer. We will use timer. This timer and data transmission. Okay, from 4 bits. Okay, this was yes 4 bits. Just the word here and 4. If we need multiple, okay, I can just use multiple station address from the one. Data range maximum you can also 8 value. But from here I will use PLC 1. This is my PLC, Mitsubishi PLC. And I will write directly that one inside this DO. Okay, D10. Okay. I will add this 2. I will copy. But I will change the address. I am using PLC1 and D10. Okay. And this one is becoming D14. D14. Okay. This is already from my PLC. D4. Right, okay. And we will check is reading or not. I'm directly reading by this model and send to the PLC in one time. Because for example, if we are reading temperature and we have some logic inside the PLC, or we will make some control according to our temperature, so you need to do like this. Okay, from me, what is happened? Just you can see one temperature I have, one another one is sometime is playing. Just need to curve what is happening here. One time we tried to just use two timer I try, but what is the problem here? This is my timer or just one. Okay, so I will use another timer to number 14, address is 5, and for example 14. Okay, this is 14. Compile and download again. I found the problem, and the problem was I have some ladder program inside the PLC, and this register was busy. Just now I will use this timer. For example, I will send 8 from 0, not from 1. By I register, I will use, for example, 101. Okay, 101 is first temperature. Okay, and this one becoming now 101, and this one is 100, 100. Okay, 5. Compile, and I will do download after we will see. Okay, now we can see here just the program. Now this one is my HMI memories. Also, I'm using this timer to write this temperature inside the HMI register. Also, I'm writing to HMI register, also to PLC registers. Now you can see this second one. Now this is my PLC register, and this one is HMI register. Okay. Now if I change the temperature, now I will change. $25. Now you can see inside the PLC and HMI also memories are changing. It's because the speed is different. For this one, it's a little bit lating. You put in timer high speed, directly you can see the temperature changing. So this was about this module, 16 channel temperature transmitters, and we see how to read by the HMI and how to write this value inside the PLC. And now here we use Kinco HMI, and also we use Mitsubisi PLC. So this was about this module, and thanks for the watching.